Okay, so notes 2-7 is actually very similar to notes 1-7. I think it was 1-7. Maybe it was 1-6. But it was topic 1, and we talked about the fact that a system is technically when you have one or more equations. And when we solve a system, we're talking about how many points of intersection they have. When we talk about lines, we know that lines can intersect twice, one time, or no times at all. But in this case, we're going to be talking about linear quadratic. So we're talking about lines and whether they can intersect with parabolas or not. So a line can intersect with a parabola twice. A line can intersect with a parabola maybe once. And when it intersects once, we say that they are tangent because they only have one point of intersection. So we can also say that these are tangent. But a parabola and a line don't even have to touch at all. So in this case, you can have two solutions, one solution, or no solution at all. And by solution, we really mean points of intersection. So this should sound very familiar. This should sound very similar to the discriminant. You can have two real solutions, one real root, or no real roots, which in this case would be imaginary. All right, so we'll get to that in a bit. So on Pearson, it just talks about like how many solutions does a system have. And Pearson has you graph it. But with me, I'm asking you guys to go ahead and take it a step further and use substitution to solve algebraically. In order to graph, I notice that this is a quadratic. This is going to be a U shape. It has a y-intercept of 0. And I already know that if I take 1 and I square it, I get 1. 2 squared is 4. Negative 1 squared and negative 2 squared. So then this is my parabola. On the other hand, I have a line, which is this one, 2x to the power of 1. Based on the power, I know the shape. So this is going to be a line, and this one has a y-intercept of 0, because it's adding 0, and it has a slope of 2 over 1. It's really tough to see, but you can see that they intersect at 0, 0, and they also intersect at 2, 4. So if I were to say what are the solutions, you would say the solutions are 0, 0, and 2, 4. But in this case, I'm asking how many solutions does it have? Well, I can see that there are 2 solutions. All right. If I ask you to find the solutions algebraically, because they're both equal to y, I can set them equal to each other. I'm not allowed to divide by x. Remember, because I could be dividing by 0. But instead, I realized, well, if I see a square, that means there must be 2 answers. So I'm going to try to factor. In order to factor, I must set the other side equal to 0. Then I take out a GCF of x. They have an x in common. And then from here I get x equals 0 and x equals 2. But in this case, I'm solving the system, which means I am finding the points of intersection. So once I'm done finding 0, I still have an unknown of y. So I have to plug it back in and say, well, I need to take 0 and square it, and I need to take 2 and square it. You can plug it into the first or the second. It doesn't matter. You're still going to get the same answers. 0, 4, and 2, 4. Yeah? Alright. Let me pause. Okay. So on Pearson, there was this decimals thing where you could just, like, there was pretty, well, I'll just kind of talk about it. There was the x squared, and then it had like 2x plus b. So for example, like this previous one was 2x. And if so, then you had 2 solutions. You could see that there's 2 intersection points. But if you move this red line down 1, you can see that it'll be tangent. It'll only intersect once. And if you move it down lower than 1, then it won't touch at all. So if you play with it, just do it. But if you shift 2x down 1, remember this is like 1, 1. And if I think of this as being 2x minus 1, like this. If b is greater than 2x minus 1, meaning if this is above it, then you're going to have 2 intersections. So we say there are 2 solutions or intersections. If b is equal to negative 1, like in this case, we say that there is 1 solution. But more important than that, we know that y equals 2x minus 1 is tangent to x squared. Tangent means that they touch at exactly 1 point. And if b is less than -1, meaning if I were to shift this purple line lower than -1, then eventually they wouldn't intersect at all. So we would say that there are no solutions. But trust me, it just makes more sense if you just go on Pearson and you just play with the thing that they had and they write this stuff down. That's all you had to do. Alright, example 2, it was a solve by substitution. So in order to solve by substitution, first I want you to notice that you have a U-shape with a y-intercept of -5. I also have a line, and you don't have to, but you can just quickly sketch it. You could be like, okay, 1, 2, 3, 4, 5, and then it's going to be some U-shape, x equals -3/6, so -1/2. I don't know, it's going to be something like this. I'm not sure. I'm just guessing. This is going to be a line because it's got a power of 1. But remember, when you're graphing lines, guys, I mean, I'll show you again over here. Maybe I'll wait till I show you this. But this is in standard form. If x is 0, y is -3. If y is 0, x is equal to 3/2. And then you have to do more. But really, you can try to solve by graphing, or you can solve by substitution. You can use elimination because these things cannot get eliminated. But in order to solve for substitution, by substitution, you need a letter by itself, which we have y by itself. So we're just going to replace y in the second equation. So it'll read 2x minus, and instead of y, in parentheses, I'm just going to write 3x squared plus 3x minus 5. So we have 2x minus whatever y is equals 3. I distribute the negative. Then because I see a squared, I'm going to try to set it equal to 0, factor and solve. So I have 3x squared, -3 squared. 2x minus 3x is -x. And then 5 minus 3 is 2. At this point, I'm going to try to factor. But you cannot factor if there's a negative in front. So I'm going to divide both sides by a negative. So that'll give 3x squared plus x minus 2 equals 0. Now I can go ahead and think about this. So what multiplies to 3x squared would be 3x and x. Multiplying to 2 would be 2 and 1. And if I do that, you should always quickly check. This gives you 2x. 3 times 1 gives you 3x. And to make it a positive x, this is positive, this is negative. So that's positive, that's negative. And it still multiplies to -2, and then -2 plus 3 is positive x. Alright, at this point we split it, we set each of them equal to 0, and we solve. Add 2, divide by 3, and then subtract 1. But again, this is a system, which means you have two lines. So you have a line and you have a parabola. And when we say solve the system, you're solving for both x and y. You're solving for the point of intersection. So it's not enough to just stop here. You have to plug it back in and solve for y. So I like always plugging it into the line because I don't have to square anything. So I'm just going to go ahead and plug in 2/3. So if x is 2/3 into the second equation, it'll be 2 times 2/3 minus y equals 3. So then that would be 4/3 minus y equals 3. Subtract, divide, and in the end you get -5/3. Same thing with the other one. Then I'm going to plug in x is -1. 2 times -1 minus y equals 3, which means -2 minus y equals 3. Add the 2, divide by a negative, and you get y equals -5. So the solutions in this case, because it's x's and y's, and because they're a system of equations, the solution should be the point of intersection. So the point of intersection would be 2/3, comma, the y value attached to it, and -1, comma, -5. These are the 2 points where that parabola and that line are going to intersect. And you can, forget my sketch. You should graph it on decimals and double check that that is where they intersect. What do the solutions mean? The solutions means that there are 2 points of intersection between the line and the quadratic. Alright, so now let's go ahead and solve the system. If you go on Pearson, it'll automatically be like fully graphed, but you need to know how to graph by hand. So first I imagine that this had equal, and then I'm going to graph. Well, this is a standard form. It opens down. It has a y-intercept of 0, -10, so I'm just going to start there. 0, -10. And I know it opens down. But no matter what, I need to find the vertex. So I use x equals negative b all over 2a, which means x equals negative 12 all over negative 4, which means 3. So it's going to be at 3 something. X equals 3 is pretty much our vertex. Okay, once I'm done with x, I plug it in. So 3 squared is 9, times negative 2 is negative 18, plus 3 times 12 is 36. That's 18 minus 10. So 18 minus 10 is 8. So my vertex is at 3, 8. Well, if this is 20, this is 10, so it must be like somewhere there. And then, because I know this point, I could just reflect it. And I could just make sure that when I graph, now before I connect them, because it's less than, I'm going to do a dashed. Okay. And then I need to plug in a point. I need a shade. So to shade, I plug in, I like 0, 0, which is on the outside. If it works, I shade outside. If it doesn't work, I shade away or I shade inside. So if I plug in 0, 0 into the original, this would be 0 is less than 0 plus 0 minus 10. Because y is 0, x is 0. So is 0 less than negative 10? No. So in this case, I'm going to shade not 0, 0, I'm going to shade the other side. So that means I'm shading on the inside. I'll put an X to show that like I would end up shading the inside. Alright, for the other one, you'll notice that it's a line. I know that it's a line because it has a power of 1 on the x. So 4x to the 1. So I also know that it's in standard form. And while you just have to remember, guys, if it's in standard form, it gives you the x and y intercepts automatically. So I let x be 0. In that case, y is 4. If y is 0, x is 1. 2 points are enough for a line. And if that doesn't work, you can also use negative a over b. So I'm going to go with 0, 4, which is somewhere, if that's 10, 0, 4 must be somewhere there. And then 1, 0, which is somewhere there. And then I'm just going to connect them with a straight line, as much of a straight line as I can do. I'm going to use a sticky note. It'll be something like, and before I connect them, because it's greater than or equal to, it'll be solid. And I made a note that I changed that for my notes so that you could see a little variety. Now I need a shade. So to shade, I plug in a point. I also like to plug in 0, 0, which happens to be below the line. So if I plug in 0, 0, then that's going to give me, into the original, 4x plus y is greater than or equal to 4. If I plug in 0, 0, that gives me 0 plus 0 is greater than or equal to 4, which is false. So instead of shading below towards 0, 0, I'm going to shade above. Which means that if you have to be inside the parabola and above the line, then this is the shaded region. And you can check on Pearson to make sure that that is right. Alright, backside. Okay, the back is really, really important. Because whenever we're solving, you can know what type of solutions we're going to have just by using the discriminant. So before we actually use the discriminant, you need a, b, and c, which means you have to set it equal to 0. So here I subtracted 4 on both sides and I added 3x on both sides. And then I wrote x squared plus 12x minus 9 equals 0, because that's what you get. Don't forget to put equals 0. Don't forget to keep everything where it's supposed to be. Now, the number of solutions, well, I say verify using the discriminant. So in this case, I could just go with b squared minus 4ac. And in this case, that would be 144 minus 4. And then a times c is negative 9, which is 144 plus 36, which is 180. Because he is a positive number, that means that it touches the x-axis twice. Or in this case, that means that this and this touch twice. So whenever you set them equal, you can just make it equal to 0. And using the discriminant, if it is positive, we know that there's 2 real solutions. But remember, solutions here mean how many times do they intersect. Alright, so in this case, well actually it doesn't because you don't have a y, but whatever. This means there are 2. Now it says solve the equation by writing a linear quadratic system and using the intersection feature. So literally what I did is, this is from chapter 1, you could just plug this in, y equals, into decimals. then you plug in y equals into decimals. If you don't put the y, it messes you up. Make sure you find both. And then on decimals, you're going to see that they touch at 2 points. You click on them, and then you find those points of intersections. But because this problem didn't have a y, it says, given this, how many solutions are there? There's 2. But we're solving just for x. There's no y. There's no need to plug it back in. So in this case, x's are my solutions. For the next example, same thing. I could just use, well, first I need to add the 3 over. So that's 4x squared minus 5x plus 10 equals 0. And I can use my discriminant, which is 25 minus 4 times 40, which is 25 minus 160, which I know is going to be some negative number. I don't care what it is. But because it's negative, the number of solutions is no real solutions. There's none. Because a negative means I'm going to have imaginary. So solve the equation by writing a linear quadratic system and using the intersection feature. But once I graph it, if it's negative, that means I'm going to have imaginary solutions. So again, on decimals, you can try it. You're going to graph the left side equal to y, the right side equal to y, but you're going to see that there's no intersections. And we know that there's going to be no intersections because the solution is plus or minus the square root of a negative, which means you're going to have imaginary solutions. If you have imaginary solutions, that means they don't intersect. So, oh, and then how else could we have solved for these awesome non-pretty answers? Using the quadratic formula. Alright, I hope that's enough.